This presentation is about problem-based learning, and in the context of discussing problem-based learning, we'll talk about WebQuests and anchored instruction. The pictures that I have on this page include Howard Barrow, who's kind of been spearheading problem-based learning in the medical education area, Bernie Dodge, who's kind of spearheaded the WebQuest movement, which many of the WebQuests are problem-centric. And then there's also the anchored instruction approach, which is manifested as something called the Adventure of Jasper Woodbury series of video discs that have problems embedded in them. So it's kind of a late elementary, middle school curriculum. So one's higher ed and medical education, and the other two examples are K-12 focused. Okay, so both the two models that I talk about primarily are project-based learning and problem-based learning. In this example, for today's presentation, we're talking about problem-based learning, but both of them are in contrast to direct instruction. So hopefully you've learned something about cognitive apprenticeships already. Cognitive Apprenticeships talks about how to move from being the sage on the stage to the guide on the side, and central to the idea of cognitive apprenticeships is that the students are engaged in some kind of whole task. Well, two approaches for that whole task is to either get them to engage in a project that they choose, which is project-based learning, or you design a problem for them to solve and you give them all the resources to solve that problem, and that's problem-based learning. So that's the two principal approaches that we take for doing education that's more student-centric. Okay. All right. Again, I mentioned cognitive apprenticeships. You should have already learned a bit about cognitive apprenticeships. And cognitive apprenticeships really is talking about what you need to do as the teacher. And project-based learning and problem-based learning is more about how you design the whole experience that they engage in, that you can then move into this cognitive apprenticeship model where you're modeling and then coaching and scaffolding. But what do you coach and scaffold? You coach and scaffold them as they go through problem solving or as they go through the development of some sort of project. All right, again, talking about cognitive apprenticeships, problem-based learning and anchored instruction of WebQuests. That's sort of the grist that the students are engaged in, the focus that the students are engaged in. Project-based learning chapter also talks about learning by design and constructionism. And so again, all of those are the thing that they're engaged in, the whole task that they're engaged in. And while they're engaged in that, what do you do? Well, if you're moving to the guide on the side as they're engaging in these whole tasks, well, the cognitive apprenticeship is the things that you engage in. All right, let's talk about the problem-based learning models. And really, a lot of people struggle with the difference between project-based learning and problem-based learning. And if you read the text, there's actually a link to a Venn diagram, and I've tried to reproduce that to some degree here in this slide. But the green area, the image that you get is a Venn diagram. It has two circles, and one circle represents all the things that are project-based learning, and the other circle represents all the things that are problem-based learning. And so the problem-based learning is the circle that's red, and the project-based learning is the circle that's blue, and where they overlap is where it's green. And so let's talk about the overlap, the green stuff. The thing that they share is that they engage students in authentic real-world tasks. They're all open-ended. It's a much more open-ended kind of thing. There isn't a right answer to look up in the back of the book. It's a complex problem-solving process or a complex project that they're engaged in. Projects or problems intended to simulate professional situations. They're all student-centered, teacher-facilitated. Students work in a group for extended periods of time. Almost always you have them working as collaborative. It's not a requirement, but it certainly is the typical approach. Students encouraged to seek out multiple sources of information. So a lot of the time that you spend, regardless of whether it's problem-based learning or project-based learning, is finding resources for them as they engage in either their problem-solving or their project development. Emphasis on authentic performance-based assessment. You're not going to give them a test at the end. You're basically going to assess what they learned based on what their performance on their problem-solving or their project. Ideally, both approaches provide, cut that off, I'm not sure what that is. So let's look at the, kind of hopping around here. I'm going to go back to the blue text now and talk about project-based learning. Begins with an end product in mind, not a problem. Production of the artifact typically raises one or more problems for students to solve. So this is where the ambiguity comes in, is you're engaged in a project, and as a consequence of working on the project, there are problems to solve. So is it problem-based learning or project-based learning? And again, I think that because you're starting with them saying you need to build something, you choose what it is that you're going to build, that's project-based. It's a little bit more open-ended. It uses a production model and mirrors real-world production activities. So they're going to build something in project-based learning. The other theories that go along with project-based learning is learning by design. So they're going to design something. And constructionism. And constructionism, sort of the focus of constructionism is constructing something. Students use or present the product they have created. The end product is the driving force. Content, knowledge, and skills acquired during the production process are important to success. So again, you want to have them engage in projects where they're really learning what they need to be learning as they're going about the creation of whatever they're creating. Now, contrast that with problem-based learning over on the red. It begins with a problem for the students to solve. So you spend a lot of time on the generation of the problem, and it has to be a problem that's complex, not a word problem. You don't go into your math book and pull out a word problem. That's not problem-based learning. I think for me, the typical experience from my past is I took an accounting class in high school because my dad thought that we all should know something about business, and we spent a month working on managing a business. So there was all these materials. There were checks, invoices coming in, checks. You had to bill people. You ran a business for 3 months, and all the materials were there. The problem was designed very well to be solved. And so the class period, there was no lecture or anything. You spent all day managing this business, and it was very individualistic, although most problem-based learning is more group-oriented. Problems can be framed in a scenario or a case study format. They don't have to be. They can. Often in the medical profession, you do case. You have a case that needs solving. Problems are somewhat ambiguous to mirror the complexity of real life. That's absolutely right. You don't, as I said, you don't want if the answer is 5, it's not a good problem. It should mirror real-world problems. It should be just as messy as real-world problems are. Uses an inquiry model, and students present conclusion of problem-solving process but do not necessarily create a product as a result. Defined problem is the driving force. So there's your distinction between project-based learning and problem-based learning. Okay? All right. General problem-based learning. Unfortunately, PBL for problem-based learning and project-based learning gets abbreviated the same. But general problem-based elements. It's grounded in a general question, a general problem. It's student-centered, and almost always it's collaborative in nature. And the context of the problem is when you design your course, it's a collection of problems for the students to design, and the problems define the curriculum, not the student will be not a collection of objectives, although the objectives can guide the selection of the problems to engage in. Okay, so problem generation is the curriculum. You spend a huge amount of time up front coming up with the problems and the materials to support the problem that they're engaged in. You present the problem, and then it results in them spending some amount of time. Again, one of the examples we'll talk about later is the anchored instruction examples. Typically, one of the laser discs that presents a problem, like one is Rescue at Boone's Meadow, where Jasper's up on top of a mountain and camping, and somebody shoots a bald eagle and wounds the bald eagle, and he has to get the bald eagle to the vet off the top of this mountain. And throughout the 20-minute video, there are all kinds of pieces of information, like an ultralight and a map, and with a legend to figure out distances and such. But the kids it takes them about 2 weeks of regular class period. Let's say a class period lasts an hour, 10 one-hour class periods to actually solve that problem. And if you have them work in groups, if you had 5 groups of 6, for example, working on the problem, you're likely to come up with 5 different solutions to that problem. There isn't a really clearly defined correct answer to that problem. So it has all the ambiguity of a real problem, and it's complex. Okay. The teacher role is to move more towards scaffolding and modeling. And again, to use the Rescue at Boone's Meadow, sometimes they have to perform some kind of mathematical calculations, like manipulating fractions, multiplying fractions or something. The teacher might stop and actually teach them how to do that as a separate little instructional unit, but the kids readily see the importance of knowing how to do that so that they can solve the problem that they're engaged in. So it gives them a very contextualized way of understanding what they need to learn. The student role, they're central to it, and you want them to engage in articulation and reflection as they engage in these things. Okay. All right, anchored instruction. The problem is anchored in a video context. Like I said, the example that I just described, Rescue at Boone's Meadow, you watch this 20-minute video. They spend a lot of time in the production of this video. There is lots of information in the video. Some of the information is unnecessary or irrelevant to the solution of the problem. And there's lots of data that is relevant. So the students have to wade through all of that information to figure it out. It's a compelling video. It's interesting. The kids like watching the video. There's some goofy guy. I've forgotten the name of that character, but the kids all love that goofy guy. And he winds up coming back in other episodes. And the complete collection they have, and again, as I said, it's mathematics that's at about middle school level. I've also seen it done with 5th graders. If you get a collection of those, and I can't remember how many there are in the whole collection, but let's say there's about 10 of them. They're about $400 a piece. There's probably more than 10. But that could be a significant portion of the mathematics learning that goes on during the school year if you're spending 2 weeks on each of those problems to solve. Let's see. It allows them to develop shared experience. It helps them to contextualize it. They all can talk about the rescue of the bald eagle. You can have them, part of the solution to that bald eagle problem could have been involved in an ultralight, that they may have used the ultralight to help fly up there and rescue the bald eagle. And so you can expand on the topics that come up during the problem-solving process. So you might do a science unit on flight, and you might do a social studies unit on transportation. So there's opportunities for projects as extensions or to expand into other domains to further contextualize what they're learning. Problem solving in video, and a significant part of it is collaboration. And at the end, they share what was learned, which is a part of their articulation and reflection. As I said, I looked it up. It's been a while since I looked it up. The last time I looked, you can buy those materials for about $4,000. I don't even know if they come out on laser discs anymore. It might be on DVD. I don't know. But that's anchored instruction. And obviously, you can use the ideas of anchored instruction if you wanted to in any domain. It doesn't have to be middle school math. It could be healthcare education. It could be training in business and industry. It could be any context that you use that, but you'd have to produce some video materials to give a real-world anchor to whatever problem that you're doing. WebQuests, most of the WebQuests I've seen are for children, but I've done a lot of WebQuests myself for adults. But it basically revolves around some sort of quest, and the quest almost always is a problem. And so the WebQuest, the design of the WebQuest has several components, including introduction, task, and process. There's a couple more on the next slide, including evaluation, a teacher page, and some sort of concluding activity. So it has a lot of the elements of cognitive apprenticeships. The process is really where your scaffolding occurs, and the task is where you refine the problem definition, and the introduction is the thing that gets them excited about it. So again, to map it back to anchored instruction, the video is the introduction that gets them hooked into it, really gets them interested in it. Well, in a WebQuest, you're doing this with web pages. You come up with something that hooks the learner into wanting to engage in the problem-solving process. Now, some of the WebQuests I've seen are much more project-oriented, but most of them, because of the nature of the quest that they're engaged in, is problem-solving, not necessarily project-oriented. So, but it can be project-based. So WebQuest is kind of straddling the two approaches. Okay. All right, so we have evaluation, conclusion, the teacher page, or the other elements of a WebQuest. Evaluations almost always are coming up with a rubric to evaluate the end solution to the problem, the artifact that they're creating, whatever that is. And so it's not some kind of multiple choice test that you test their knowledge at the end. It's you evaluate what they learned by what they produced. And the conclusion is really where articulation or reflection occurs. The teacher page is so that you can help others make use of your WebQuest, although I find making the teacher page is actually quite useful for me as I teach it from semester to semester to remind me what it is that I need to do to prepare to make use of that WebQuest and what my thought processes were. So the teacher page can be a teacher page for you to go back to. It could also be a teacher page so that others could make use of it. Again, so we talked about generically the idea of problem-based learning. We've talked about anchored instruction, and now we've talked about WebQuest. And so that's problem-based learning. You learn what you need to learn in the context of solving a problem. You don't have a separate activity where you learn stuff. The Barrow work on problem-based learning in the medical field was a direct result of medical students going through a medical curriculum in such a way that they could generate the answers for a multiple choice test, but when they actually were working with patients, it wasn't really clear how to make use of the knowledge that they had learned in medical school to help with that particular patient. And what he found is that if you get them to learn all that stuff that they're going to need to know in order to pass that test, but you do it in the context of working on these cases, that they're learning it in such a way that they can pass the test, but they're also learning it in such a way that they can also work with patients. So it becomes a much more useful way of learning the information. Each Jasper estimate, and I think I've said this already, each of the anchored instruction videos takes about 1 or 2 weeks to solve. So it's a complex, problem-based learning is a complex process. It's not something that you solve the problem in an hour. It's something that you have to really spend time on. And then WebQuests are typically posed as a problem, but not always. Sometimes it's more project-based learning. Okay? So that's problem-based learning, and I'm going to work on a little bit later some presentation on project-based learning, and so you can find out about that. But those are the two main approaches to getting learners engaged in some kind of an activity that you can then make use of cognitive apprenticeships to support them in whatever thing they're engaged in. Okay? Have a good day.